السلام عليكم ورحمة الله وبركاته. This is Yusuf Abdulwaḥid Mansour. I have a PhD Civil Engineering. My specialization is bridge and tunneling from Southwest Jiangtong University, Chengdu, China. I joined University of الانبار in 2005 as assistant lecturers, and I got my second permission as assistant professor in 2005. My responsibility is to teaching, in addition to member graduate comment. I'm teaching course computer program, language programs, statistics, static engineering, traffic engineering, construction building for undergraduate, and for postgraduate advanced concrete bridge. Today, my lecture will be as introduction for postgraduate courses for bridge engineering. The title is Bridge Load Combination and Factors according to Ashto LRFD Bridge. The headline for lectures is, and the content of the lecture today is, what is a bridge? And Ashto LRFD overview, loads definitions, bridge loads classification, gravity load, and dynamic load. At the beginning, what is a bridge? Bridges is inspired by nature itself. They are part of environmental, as we see in the pictures. We can define the bridge as a structure which covers a cup. Generally, a bridge carry a road or railway across a natural or artificial obstacle, such as river and canal and another railway or another roads. The picture shows the first bridge was in 1819 in London. And we can say the bridge is the key element in the transportation systems. And if the bridge fails, the whole system of transportation fails. For example, sometimes there are some problem having in the roads. Appear some crack, appear some another problem. But the flow of traffic will not stop while when any problem happen for a bridge, such as corrosion reason and the crack appear. That means the traffic flow will stop. This is what the meaning of if the bridge fails, the system of the transportation fails. I said all the ways the corrosion is a cancel of reinforced concrete. It is as hashtag because you know the corrosion. It is the reason for many deformation in the bridge. We can classify the bridge according to the material as steel bridge, concrete bridge, wood, hybrid, stone, or brick. According to usage, pedestrian, highway, railroad. According to span, short, medium, long. According to structural form, slab, girder, truss, arch, substantiation, cable stay. And according to the structural arrangement. Then normally bridge divided two parts, substructure and superstructure. The substructure include pier, apartment, and foundation. Superstructure is girder, dig, and surfacing, and another things. As we see in the picture, the foundation, the pier, apartment, and girder, and we see the digs, expansion joint, and other facilities. Ashto basic assumption. You can see to understand the idea of specification for a bridge, we saw the pictures. They are dialogue between son and father. When the father drive on the road, the son saw some limiting. Say, how do they now the load limit on a bridge? The father said, the father thinking and said, the drive bigger and bigger truck over the bridge until it breaks. Then they weighed the last truck and rebuilt the bridge. Actually, this is logic, but it is not true. But it is given as idea about how they put the specification. The special specification for a bridge is called LRFD, Load and Resistance Factor Design. The basic conception for design philosophy: first, it is not economical to design a bridge so that none of its components could ever fail. It is necessary to establish an acceptable level of risk or probability of failure. To determine an acceptable margin of safety, opinion should be sought from experience and qualified group of engineers. A general statement for assuring safety in engineering design that the resistance, it comes from material, stiffness of material, of course, and geometric design of member, you can say X section, should be more than effective of applied load. History and need of a bridge specification. Statistics of built-in bridge in 1870 show there are more than 40 bridge failed per year. It is not economical and big losses. So the first practical step was taken after the collapse of locomotive bridge in 29 September 1876 across at Ohio City. After that, in 1914, appeared American Association of State Highway official ASHO. In 1963, ASHO became ASHTO, American Association for State Highway and Transportation Official. In 1986, the subcommand of a bridge and structure is initiative study of the load and resistance factor design. The subcommand authority of comprehensive rewrite of the entire standard specification to combine the conversion to LRFD. The result is the first edition of ASHTO 1994. This is LRFD. Load and resistance factor design. The law it comes as an alternative to the ASHTO standard specification. Present minimum requirement necessary to provide for the public safety. Higher standard can be imposed. The engineer is responsible for safety design. The LRFD method was developed, which is based on strength of material, consider variable not only in resisting but also in the effect of loads, provide a measure of safety related to a probability of failure. And for these things, you need a huge of data to estimate the load modify factors and resistance factors. As a general, resistance have two more than load effect, and we see the equation. They are load modified, they are load factor, and they are load for forces effect, and they are resistance forces and nominal resistance. Loads. Load, it is the effect of acceleration, include that due to gravity, while the nominal load is design load. Load factor is that this coefficient experiences a probability of variation in the nominal load for expected surface life of a bridge. The permanent loads or forces which are assumed to be constant of in computation. Forces effect, meaning the deformation such as stresses come from shear, torque, moment, it caused by load and another. A structure engineer has to make a structure safe against failure. The reasons for structure being not susceptible to failure are the load that construct will be called open to resistance and cannot be predicted. The strength of various compound cannot be assessed with the full assertion. The condition of structure may be developed with the time, causing it to lose strength. Load classification. Gravity load. You can go to ASHTO section 3.5 page 75 to know about the definition of a gravity load, such as permanent load, constant, which means constant magnitude and location. While the transit loads, it is variable magnitude and location. Construction load will not include in the LRFD the lateral loads and forces due to deformation and collision load. The permanent loads is dead load, for example, self-weight of concrete, and the density is 150 BCF, while the density for steel is 490. The future wear surface for asphalt normally it to 25 BSF. Another facilities, we can see it on the table. It's easily to calculate by know the unit weight of it and the geometric design, the dimension, and you can find the load. Permanent gravity load are the load that remain on the bridge for extended period of time or for the whole surface life. Such loads include section A3441 and A3412 from ASHTO, and classified to dead load of structure compound, dead load of wearing surface, dead load of earth fill, and earth pressure load, earth surface load, and down drag, which we use for just only piles. Dead load of structure compound and non-structural attachment. In bridge, structural compound refers to the elements that are part of load resistance. Non-structural attachment refer to such as items as a curve, rails, signs. Weight of such as can be estimated by using unit weight of material and geometry. Load factor, you can go to the tables A3411 and A3412, and you can know the modifications factors. Load factor, sorry. Dead load of wearing surface. This load is estimated by taking the unit weight times of thickness of surface. I mean the thickness of asphalt surface. This is values combined with the DC load power per table A341. The maximum and minimum load factor is between 1.25 and 0.9, while for DW is 1.5 and 0.65. Dead load of earthfall. This load must be considered for base structures such as culvert. I mean the layers of subbase which will be over the culvert. We call it dead of load of earthfall, and easily you can calculate by the thickness of layers, multiple layers, and multiple by unit weight for each layers, and the depth. We can find the dead load of earthfall, and we can calculate the load factor from table A3411 and A3412. AV has a maximum and minimum load factor between 1.35 and 0.9. Same thing for earth surface load. The earth surcharge load, which comes from lateral, especially on the apartment, and we can also calculate in the same thing. There are layer of soil and thickness for each layer, and the dimension, and they are unit weight for each layer. You can calculate the load. Dragon down that you use for when you use a pile or drill shift due to the soil movement around the elements, such as forces is permanent and typically increase with the time. Actually, you can go to the section term and to get more details about the DD. Transit loads, it is more effective load on the bridge, because the main load is coming from traffic, pedestrian, and heavy traffic load also. And as the name, these loads change with the time and may be applied from several direction or location. Therefore, it is changed with the time, the volume change with the time, and also change with the directions. Transit load typically include gravity load due to the vehicular or rail or pedestrian traffic, as well as lateral loads such as those due to wind, water, ice. Live load, it's in section 3661 and 3613, page 76 and page 96. And there actually the meaning of the fatigue load, they are repeated load on the specific area, and when you circling the loads for many times over the specific area, maybe it causes fatigue deformation. That fatigue can come from repeated load, it's called fatigue. Section 3614. Vehicle dynamics load allowance and wind and many other. All these type of transit load. Vehicle live load history. Actually, because we deal with the bridge, so they are you have to fix the type of a truck and dimension of truck as design. In 1913, in Washington was the first state to place limits on truck weight to protect highway, bridge, and pavement. In 1933, all states had a limit of some kind. In the early part of last century, design utilized a train of truck as design load for their bridge. It was determined that a standard set of design load caused by truck traffic needed to be developed. More recently, in 1944, HS-20. H is highway, S semi-trailer, 20 weight of tractor in ton. For transit load, each code has described the following criteria. And according to LRFD specification: design line, vehicular design load, fatigue load, pedestrian load, dig and railing loads, multiple presence, dynamic effect, centrifuge forces, braking forces, other. What is the meaning of design load? First, I have to. There are two things. They are traffic line and they are design line. The traffic line is designed by traffic engineer, while the design line is designed by the structure engineer. According to ASHTO, uses a 3-meter design line, and the vehicle is to be positioned within that line for extreme effect. The number of design lines is defined by taking the integral part of the ratio of the clear road width divided by 3.6. The clear width is distance between the cap and pairs, to cap or pairs to pairs. In cases where the traffic lines are less than 12 foot wide, the number of design lines shall be equal to the number of traffic lines, and the width of design line is taken as the width of traffic line. For roadway width from 20 to 24. Vehicular design line. Actually, the specification, the specification of all RFD is dependent on depended on the idea that the resistance more than the effective load, and they calculate many load factors and resistance factors. For load, we said there are gravity load, which is fixed on the bridge for whole the life surface of the whole life of a bridge, while the transit load, which is moving. We designed the bridge according to model for dynamic loads. That model is include design track, design tandem, design line, and we calculate for each one and take the more critical one. For design track, we design a track as we see for 3 axle, and this is the distance between axle load is fixed, as we see there. In the front 35 kilonewton and 145 and 145 for another axis. حقيقة تغير المسافة يؤثر على تولد العزوم، وخاصة بالنسبة للعزم السالب. لذلك صمم هذا الموديل ليكون ثابت في عند التصميم في الجسور، حيث انه المحور الاول يحتوي على 35 يكون 35 كيلو نيوتن، بينما المحورين الاخرين 145 والمسافه بيناتهم تكون ثابته. while for more information we call it model HL93. H for highway, L for RFD, at 93 this is the year which devoted the idea. The second configuration is design tandem and is illustrated in figure below. The design tandem is taken 2 axes weighs each one 110 and the space 1.2 meter. A tandem can be defined as 2 closely spaced and mechanically interconnected axes of equal weight. This is the shape of tandem, 25 and 25. Design line load. The design line load, the third load, is design line load that consists of a uniformly distributed load, the value of 9.3 Newton over millimeter, and is assumed to occupy a region 3 meter. 3 meter is same the width of design line. The load is same a uniform pressure of about 64 pound over foot applied in 10 foot design line. The load of design track and design tandem must each be superimposed with the load effect of the design load. This combination of load and axle load is a major deviation from the requirement of the early H2 standardized specification, where the load were considered separately. In symmetry, design load should be considered the design track, design tandem, and design line. These loads are superimposed three ways to yield the live load effect, which are combined with the other load effect as shown in the table. The table shows live load combination, design track, design tandem, to design track, to tandem, and design load. The above mentioned three cases are stated in the table where their number and tables indicate the property multiple to be used prior to superpositions. Limit state. The limit state is, as we said, actually we designed the bridge according to idea, the resistance more than the load factor. The resistance, it comes from the strength, and the strength is come from material and the shape of elements structure. This is their condition will be bound with the structure. It's effective on the bridge. We call it limit state. A limit state is a condition bound which a structural system or structural compound ceases to fulfill the function for which it is designed. A bridge shall be designed for a specific limit state to achieve the objective of construction, safety, and serviceability. Generally, the limit states that are considered in the bridge design are: the strength limit state is related with stiffness and control on the deformation, while the surface limit state is related with the crack and control on crack and ductility. The fatigue and the fracture limit state, it comes from repeated load and what that can causes on the bridge. Extreme event limit state. The extreme event limit state, it comes from some, for example, seismic analysis, earthquake, and another overloaded factor. Actually, for each limit state, for example, for strength limit state, there are three types: strength 1, strength 2, strength 3, and strength 4 and 5. For surface limit state, there are three types: surface 1, surface 2, surface 3. And there are loads, it comes from gravity load, especially DC, from compound structure, DD and DW and EH, EV, ES. And there are factors for, we call it load compound factor. For load factors for permanent loads, there are another table in 3412. This type of load called compound and attachment use one of these and they are maximum and minimum. That means we will design for two cases. We calculate for minimum and we calculate for maximum and choose the critical one. Actually, this was introduction for loads, type of loads of the bridge, and how we can calculate according to the safety equation. Inshallah, in the next lecture, we will go to how can analysis the structure according to the type of the loads, and I hope from all the students go to the references to Al-Arabi Bridge design specification 2014, and also there are important book we call it Design of Highway Bridge and Al-Arabi Approach for Richard and Barker for Willie. This books is so important because you have idea, examples and procedures to design the loads. The most important for me, I depended on that book for design bridge, and he classified the bridge to the concrete bridge and the steel bridge. We will focusing on the concrete bridge because that's so important things. This was my first lecture, and I hope you're interested in these lectures. Thank you very much.